All right, for these last, I think 3 problems, we are finding area. So this first one says find the area of the region bounded by the graphs of y equals 12 over x squared plus 5x plus 6, y equals 0, x equals 0, x equals 1. So anytime I'm doing area, I think it's a good idea to graph. And let's see. I'm going to do this one non-calculator. So yeah, I'd like to graph this. So I'm going to plug in x equals 0 to see what I would get on the y-axis. So if I plug in 0 here, I get 12 divided by 6. So we're at 0, 2. And then we're stopping at x equals 1. So when we plug 1 into this, we get 12 over 1 plus 5 plus 6. So that's 12 over 12. Okay, so we have some sort of a curve like this, and there's a line at x equals 1, x equals 0, y equals 0. So we're just talking about this area right here. All right, so that tells me I should be taking the integral from 0 to 1, the x values, of top minus bottom. So 12 over, let's go ahead and factor this, x plus 3, x plus 2, dx. And I can split this into partial fraction decomposition. So if I let x equal negative 3 and I cover up x plus 3, I'm going to get 12 over negative 3 plus 2. So that's negative 12. And then if I plug in negative 2, I'm going to get 12 over, cover up the x plus 2. So 12 over negative 2 plus 3. 12 over 1 is 12. So there's a negative 12 in front of the integral from 0 to 1 of 1 over x plus 3 dx. And then there's a positive 12 times the integral from 0 to 1 of 1 over x plus 2 dx. And we can integrate each of those. So, and actually, I mean, we have the same bounds. There's a constant I can pull out. So I would like to pull out the constant, 12. And then when I integrate, I'm going to do the positive term first. So natural log of the absolute value of x plus 2, and then minus the natural log of the absolute value of x plus 3. You don't have to switch the order like that. I just like the way it looks better. And we're evaluating from 0 to 1. So if I plug in 1, I get natural log of 3 minus natural log of 4 minus, if I plug in 0, I get natural log of 2 minus natural log of 3. And then let's see. So this is combining some like terms here. So this is natural log of 3 plus natural log of 3. So I have 2 natural log of 3s. And then what about this? Minus natural log of 4. Remember, 4 is 2 squared. So I could say minus 2 natural log of 2 minus natural log of 2. Do I have to go through simplifying all this stuff? No. But I was just trying to combine like terms. So I'm just kind of showing you some possibilities for what we might, I don't know if they would really do this to us or not, all of this natural log work for a multiple choice question, but I'm just showing you where things could go. Or I could also just like do the math. If I left this as natural log of 4 minus natural log of 2, we can still condense everything, right? So we could say, oh, this is the natural log of 3 squared is 9 minus the natural log of 8. And so that's 12 times the natural log of 9/8. So I don't know. Maybe we take it that far. I have a 12 out in front, so I could pull that to the 12th power as well if I wanted to. So, whatever. I'm going to leave my answer like that. That's probably more simplified than it needed to be. I could have also just left the answer, way back here. Depends on what I'm doing with this. Excuse me. Find the area of the region bounded by the graphs of, okay, so similar, just a different function for this one. So let's go ahead and graph it first. Let's assume it's no calculator. So our bounds are x equals 0 and x equals 2. So go ahead and plug in 0, and you get 15 over 12, reduce that by 3, so 5/4. I guess, it doesn't really matter for these because everything's in terms of x's, what this point is. I just think it's smart to graph it accurately so that if you needed to know that y value, for some reason, if we were going to rotate this in a next section or something, we would have that information. If you plug in 2, you get 15 over 4 plus 14 plus 12. That's 15 over, let's see, 14 plus 16 is 30. So that's 1/2. I'm not too worried about scale. I know it's a rational function, so it's going to have some sort of curve like that. And again, we're just looking at this area. All right, so this area is the integral from 0 to 2 of 15 over, let's factor this, x plus 4 times x plus 3 dx. We'll use partial fraction decomposition. Sometimes I set it up like this, give myself space for coefficients. I guess I haven't been doing that, but a lot of times I do. Set it up like this, then I'm like, okay, so if x equals -4, if I cover up the x plus 4, I would get 15 over -4 plus 3. So that's -15. And then if I plug in -3, I get 15 over -3 plus 4, because I'm covering up the x plus 3. So that's +15. Oops, and we're going from 0 to 2. I dropped my limits there. Okay, so then let's do the same thing. Factor out of 15. And then this is going to be the natural log of the absolute value of x plus 3 minus the natural log of the absolute value of x plus 4. Evaluate from 0 to 2. When I plug in 2, I get natural log of 5 minus natural log of 6 minus, when I plug in 0, I get natural log of 3 minus natural log of 4. And how about we just go ahead and condense things? So this is really minus natural log 3 plus natural log 4. So let's just condense this all together. This is the natural log of what? So we have 5 on the top. There's a 6 on the bottom. Minus 3, so times 3 is going to go down here. Plus 4, so plus 4 is going to go up here. And then we could reduce like this. This is 20 over 18, or I would just do reduce here. So 15 times the natural log of 10 over 9. And that could be the natural log of 10 ninths to the 15th power, whatever that might be. Okay, so I think that's as far as I would take number 60. Again, for free response, you do not have to condense all the way down. But if we're looking at multiple choice answers, I would bet that we're going to see condensed answers. Okay, for number 61, again, it's an area problem, and this is our last problem. This is our last problem, area again. So area bounded by the region y equals this and y equals 1. So let's go ahead and graph this. Now y equals 1 is the line y equals 1, right? Like a horizontal line like this. Okay, so where does 1 equal 7 over 16 minus x squared? Because I want to know where do they intersect and is this graph above or below 1 or what? So I'm going to multiply 16 minus x squared times 1 to the other side. Subtract 7, add x squared over. So this is plus or minus 3 is equal to x. So my graph is a bit off. Let me readjust here. Put this more in the middle because I'm at -3 and +3. Okay, now 7 over 16 minus x squared, what does that look like? So we know that the graph hits 1 here and here. It's probably one of these like kind of bell-shaped curve looking things, but if you're not quite sure, remember you can also plug in 0 for x, and that gives you 7 over 16. So is the bell going up or is the bell going down? Well, 7/16 is below 1. That's 7/16. So it's some sort of curve probably like this. I might have the concavity wrong on that. yeah, I'm not too worried about it. But yeah, as it would have it would have a horizontal asymptote of 0, wouldn't it? I don't know. Whatever. The concavity is. I'm only looking at this section. Concavity is irrelevant if we're talking about area. So I'm just trying to get a general shape of what is on the top and what is on the bottom. So this is our first one where we actually do have. It's not just the function, the integral of the function. Top minus bottom is equal to, the line is on top, so 1 minus the function 7 over 16 minus x squared. Okay, so this area, I'm still using x values. I'm going from -3 to 3, but I need to do 1 minus 7 over 16 minus x squared as my integrand. And then when I integrate this, now the integral of 1, let's just go ahead and do that. The integral of 1 becomes x, and you've got to evaluate that from -3 to 3. And then you're subtracting 7 times the integral from -3 to 3 of 1 over 4 plus x, 4 minus x. Now, here's something you could do. It's going to come out the same way either way. And I did not do this on my answer key. And I guess I won't fully do it here. But you could factor a negative out of this to make it x minus 4. And then that negative would make this a plus. But I'm not going to do that because I'll try to keep it the same as what I posted. Okay, so this, first of all, is 3 minus -3. So this is 6. And then out here, we're going to have something times the integral of 1 over 4 plus x dx, and something times the integral of 1 over 4 minus x dx. Both of those are going from -3 to 3. They both have 7s in front. I'm just pulling that out in front here. So what would those be? So if we plug in x equals -4 for the x plus 4 denominator, cover up the x plus 4. 4 minus -4 becomes 1/8. So there's a positive 1/8 out in front of here. If x equals 4, I'm covering up the 4 minus x. I get 1 over 4 plus 4. I get positive 1/8 for that. Okay, so this is, oh, no, wait. I almost made the same mistake I made before. What am I forgetting here? I just jumped right in. There's a little bit of u sub needed. If I forget this, which I did when I was making the key, you'll get 0 for your area, and clearly the area is not 0, so for that section. So, okay, there is u sub happening, right? Because u would be 4 minus x. Maybe I should have factored the minus out, huh? U would be 4 minus x. Du dx would be -1. So if I want to have a u in here, I need to have a negative out in front. So even though this came out to positive 1/8, it's really going to be negative 1/8 because of u sub. Okay, so that's tricky. All right, and then this becomes 6 minus 7 times, oh, you know what? Let's just pull out the 1/8. So minus 7/8. So natural log of absolute value of 4 plus x minus natural log of absolute value of 4 minus x from -3 to 3. And that's 6 minus 7/8 times, so let's plug in 3. So natural log of 7 minus natural log of 1. Remember, natural log of 1 is just 0. And then minus natural log of 1, which is 0 again, minus natural log of, so 4 minus -3 is 7. So the zeros are not there. We have, this will be natural log of 7 plus natural log 7. So we have 2 natural log of 7s in there, multiplied by 7/8 negative. So 6 minus 7/8, which we can clean that up. 6 minus 7/4 natural log of 7. So because of that tricky u sub, now that makes me go back and think I probably should have done this. Actually, from way back here. I should have said, let's not let this be backwards. Let's make it 1 plus 7 over x squared minus 16. And then I wouldn't have had to worry about u sub because I'm going to say this. No u sub needed. Because both of the u's would have been x plus 4 or x minus 4, and so I wouldn't have had an issue. So that would have been smarter for me to do there. All right, that finishes up these last 3 problems. And please make sure you're coming into office hours if you have questions on any of this stuff. There are a lot of steps now that we're in the BC content.